Yeah, good day, viewers. Now, we have this OCR A-level chemistry question from the past. And what does the question says? It says bromine reacts with fluorine to form a compound A. Compound A is a liquid at room temperature and pressure, but can easily vaporize. When vaporized, 0.428 gram of that compound A produces 76 centimeter cube of gas at 1.00 times 10 raised to the power of 5 Pascal and 100 degrees Celsius. We are asked to determine the molar mass and the formula mass of compound A now, which means that bromine actually reacted with fluorine. Fluorine is a gas, bromine is a liquid, to form a compound A, which is actually a liquid. We don't know. Now, on the question, we have that the mass that actually vaporize, the mass of compound that vaporize is 0.428 gram. We are given the mass, and also we are told that it produces 76 cm cube. So now the volume given in the question is 76.0 centimeter cube. Then we have the pressure given. Pressure has been given to be 1.00 multiplied by 10 raised to the power of 5 Pascal, the name of the scientist there, and 100 degrees Celsius. That is the temperature. The temperature is 100 degrees Celsius. We are asked to determine the molar mass, MR, and also the molecular formula of compound A. So in this question, we are asked to determine two things: the molar mass MR of compound A, and at the same time the molecular formula of compound A. So now, what do we do first? This volume we need to convert to meter cube, and at the same time the temperature we need to convert also to Kelvin. So how do we convert the volume first? Now we convert this to meter cube, and that's going to be 76, all right, multiplied by 10 raised to the power of -3. This is in dm cube as it is here. And to convert it to meter cube, you have to multiply again by 10 raised to the power of -3, and the volume will eventually be 76 multiplied by 10 raised to the power of -6 meter cube. All right, so we have converted from centimeter cube to meter cube. Now at the same time, we have to convert the temperature, which is 100 degrees Celsius, to Kelvin, because compound A is a vapor. So we have to, the unit should be in Kelvin. So that's going to be 100, all right, 100 plus 273, which is the standard temperature. So that will be 373 in Kelvin. Now, given all the parameters we have here, we got mass, we have volume, we have pressure and temperature. The equation which we're going to use is the ideal gas equation. We're going to apply the ideal gas equations, which says that for an ideal gas, PV is equal to nRT is equal to nRT. But we know that number of mole is equal to mass divided by the MR, which is the molecular mass. So how do we do that? So PV is equals to mass divided by MR, then R multiplied by T. Now this R here is known as the molar gas constant, and it has been given to be, it has a value of 8.314. all right, 8.314 joules per mole per Kelvin. That is the value of this R. Now when we rearrange this equation, when this equation is arranged for us to get the MR, the molar mass, the formula mass, so now we're gonna have that MR will be equal to mass multiplied by the molar gas constant R multiplied by temperature divided by pressure and then volume. All right, so now let's substitute the values that we got in the equation from the formula, and this is the mass 0.428. all right, we write it in place of mass 0.428 multiplied by the molar gas constant 8.314 multiplied by the temperature, which is 337 divided. All right, so now what is the pressure? The pressure has been given to be 100,000, which is 10 raised to the power of 5. all right, and the volume is 76 multiplied by 10 raised to the power of -6. all right, so now that we're gonna work out, now 0.428 multiplied by this, and that is 1327.28016, okay, for the numerator. Then for the denominator we have 76 multiplied by 10 raised to the power of -1. That is 5 plus -6, which is 5 minus 6. Okay, that is 76 multiplied by 10 raised to the power of -1, and that will be equal to 1327.28016 divided by 7.6. all right, so when you solve that out easily, you're gonna have 174, okay, 174.6 gram per mole as the molar mass, and on approximation we have that to be 175 gram per mole as the MR, the molar mass of compound A. all right, so now that we've gotten the molar mass of compound A, now what should be the product of what would the product be for us to get a formula mass? Now when we react bromine liquid with fluorine gas, okay, on reacting bromine liquid Br2 liquid plus fluorine gas, and now we're gonna have bromine pentafluoride. All right, we're going to have bromine pentafluoride, so we balance up the equation. All right, now when fluorine gas reacts with bromine, we're going to have bromine pentafluoride. Now when we calculate the formula mass, okay, the molecular formula of bromine pentafluoride is going to be approximately equal to 175 rather. So now we have to calculate this for it to be this, so we can confirm. Now for bromine is 79.9, and the MR for fluorine is 19, right? So we have to calculate the molecular mass for this, and we must get 175. So now the formula is BrF5. So that's going to be 79.9 plus 5 multiplied by 19. All right, so when you multiply this by 19, 79.9, so this is found to be 95. So on adding 95 to 79.9, and that is 174.9, which is approximately 175 gram per mole. So definitely the vapor which is being formed is bromine pentafluoride. Thank you.